Hello, and welcome to the session. I'm Shri, a solutions architect with AWS. I work with software companies and SaaS organizations. And I'm excited to be joined by Don and Matt from CultureAmp, who will share their journey of empowering development teams. I'll start the session by briefly covering the significance of empowering individuals and teams. Don will then share distinct insights about enabling and equipping developers. Matt will showcase a demo which manifests the principles and practices as code libraries and workflows. World around us is dynamic. Customer needs and market demands are constantly changing. As individuals and teams, we have to adapt and respond to the changes in an effective way. Now, imagine an air combat situation. Each fighter pilot will experience rapidly changing circumstances. So John Boyd was a military strategist who studied these situations and established the principles to enable the pilots to act decisively and, importantly, autonomously. It was called the OODA loop, a short form of the collective verbs you see on the slide. Observe the changing circumstances, orient to the situation to gain and confirm information, make a decision, and act according to the new information. Although there is a lot more to it, I'd like to highlight a particular learning. That is, to act swiftly, put the decision-making authority where the data and information is emerging from. In other words, empower and equip the teams that are closest to the opportunity because they are best placed to find an apt solution. Now, if we take that learning to a more relatable world of software product development, it is the product and development teams that are closest to the evolving customer expectations and the ever-shifting market dynamics. Therefore, it is not a surprise that in recent years, across many organizations, we are noticing that teams are given increasing autonomy to move at speed that they believe will best address the customer needs. As products and features grow, invariably the development teams will expand. There is then scope to enable them with common capabilities that will give them more speed, and also to drive consistent operational and security baselines across the teams and environments. Let us hear from Don and Matt about their journey in equipping development teams to go faster.
Thanks for that introduction, Shri. As Shri said, I'm Don Buchanan, and I'm the Engineering Director, Site Reliability at CultureAmp. CultureAmp's mission is to make the world of work better for at least 100 million people. We do this through engaging with HR leaders, managers, and all employees through our products to enable them to create the ideal culture. We have helped over 3,500 companies from all over the world and are constantly expanding and improving our products to drive this mission. To achieve this at CultureAmp, we want all our product teams to be autonomous and independent. When they have a solution, they should be able to take it all the way to production with the minimum of steps and dependencies on other teams, while maintaining security and reliability. We strive to make it easier to stand up new services while not taking away, in fact enhancing the ability of teams to innovate. This is critical to support our tech vision, allowing us to get features in the hands of customers faster, observe how it performs, decide how to improve that feature, and act quickly to get those changes back out to production and start observing again how well our action is performing. CultureAmp was originally a small startup, and its main product was served mostly by a single monolith. This is great for the first stage. However, as we wanted to accelerate our product development and as we increased the demands on the monolith, we realized that we would need to start breaking this down and begin building smaller, more independent services. The first few services stood up around the monolith were developed with CloudFormation. CloudFormation templates gave us the benefits of consistent deployments, reliable provisioning, and allowed us to treat infrastructure as code. Each service had its own templates that gave the service full freedom to define the infrastructure as needed. We maintained security guardrails by reviewing changes to templates and restricting who could deploy changes in production. However, there were two limitations we ran into. First, the knowledge of CloudFormation templates was limited to a few people, and generally a team would copy-paste an existing template rather than craft something that matched the needs of the service exactly. Usually, it required SRE to step in and help at this stage, taking resources from the team. Secondly, due to our security concerns, the deploy roles for everyday deploys were extremely limited, only allowing for changes to task definitions. Definitely no IAM changes to prevent privilege escalation or bigger infrastructure modifications. The tech we had chosen had constraints. To maintain security, we had created suboptimal processes. We had created a hard dependency on SRE and security to review any template changes, and then an actual person from SRE to trigger any initial deploys or subsequent infrastructure changes. As you can imagine, this did the opposite of what we wanted. It slowed everything down. It could take up to 6 weeks to get a simple service into production. While CloudFormation met our need of starting to develop outside the monolith, we could see that it was unsustainable if we wanted to increase the number of services. An example workflow might have gone like this. Copy and paste a CloudFormation, change it for the project, and then to get it working in the development environment by actually trying to deploy it. After a few missteps, we would go to the next stage. We would then get it reviewed by SRE and security, and then finally get it deployed to a production AWS account by someone in the SRE platform team. Of course, if an issue was found, more changes would be made to the template, reviewed again by SRE and security, and again deployed manually to production. CloudFormation templates are very different from the normal developer experience. At the time, there was limited inline help when authoring templates. Even if a developer wanted to make a change, it was hard to tell if the change was correct or would it even work. To check if it would work, they would have to deploy it to dev for real, creating a very slow feedback loop. To be autonomous, our teams need an environment where they get instant feedback on errors while they are in their IDE. They want to be able to write tests, they want to be able to easily reuse the components they create, and they want to use a language they are familiar with. I had seen CDK from my time with the AWS Dev Alliance and was keen to try it to solve some of our problems. We set about converting one of our services to CDK. As like all things, it took a lot longer than we expected. However, once we were done, we had moved quite a complex service with many different templates to a single CDK app. The benefits were immediately visible. We were able to start to group logical components into constructs, and it was so nice just to write a single function call to grant a service's read access to an S3 bucket. We also created a code to automatically approve an ACM certificate for SSL, which of course is now built into CloudFormation, but back then it was extremely gratifying to remove that manual step. However, we didn't have inbuilt guardrails. We still needed someone from SRE to push that button to deploy to infrastructure. Our engineers could now observe their infra code, change course, and decide on alterations, but they still couldn't act autonomously. At the same time, Matt Tapper, a lead in the SRE practice at CultureAmp, was leading a project called Silk to automate the provisioning of a new service, setting up build pipelines, ECR repos, and other base infrastructure. With the addition of permissions boundaries, we solved the issue of the deploy roles escalating privileges by creating more power roles than themselves. Briefly, with permissions boundaries, you can create a role that can create other roles only if they have certain permissions boundaries attached. This permissions boundary will then limit any IAM actions that are applied to the created role. However, how are we going to create these fine-grained deploy roles and their associated permissions boundaries? CDK was chosen here to create a program that takes a config file for each service. This config file lists desired permissions and then using our own constructs creates the roles required in each of our environments, tightly scoped to that service. This config file is part of a pull request that can only be approved by Senior Engineering Management or SRE. These roles are more capable, yet more tightly scoped than the old roles, allowing the entire infrastructure to be deployed automatically, meaning we can go to production without any manual intervention by an SRE, providing guardrails so that deployed services can't step out of the prescribed boundaries. This now allows product teams to act on their observations to get their work into the hands of customers faster. These guardrails come from a set of whitelisted capabilities. We'll see how easy it is to expand that list later on. Actually, before we go further, let's take a step back and talk about CDK a bit. At the lowest level, it is a set of classes called Level 1 constructs that are an exact mirror of CloudFormation resources. In fact, they are automatically synced to the spec. Even at this level, accessing these constructs in code gives us the advantages of a familiar language within IDE and abilities to write unit tests. Level 2 constructs abstract away some details of the resource, introducing convenience methods, defaults, and glue between constructs. And finally, higher order constructs compose these level 1 and level 2 constructs into larger abstractions, wrapping up an entire pattern into reusable components. A great example from the CDK itself is the application load balanced Fargate service construct that provides an A or B, a Fargate service, optional SSL capacities, all glued together correctly. These constructs make up a stack, and stacks can be linked together in an app. Interacting with AWS via the CDK CLI has easy commands to create templates and other assets, then assemble them to be deployed to AWS itself. A lot of the heavy lifting of going from infrastructure and code to something actually running in AWS is done for you. We noticed this ability to roll up resources into higher order constructs and then compose them to even more powerful entities. We immediately started creating these constructs for both the Silk work and for any services that were moving to CDK. We created our own CDK constructs library to house this work and published them internally for use throughout CultureAmp. Because the language we used for CDK was TypeScript, most engineers were comfortable looking at it, understanding it, and even comfortable making small changes to the code. With great inline help and documentation, anyone could change the constructs either we or AWS have created to suit the needs of their project. Early on, one of our engineers wanted to incorporate AWS Translate into their service, but we hadn't enabled that with our deploy roles and permissions boundaries. They simply submitted a pull request that added this capacity to our constructs. It was approved the same day, and that engineer was immediately unblocked. But more importantly, now anyone else who wanted to use Translate could do so independently from our teams. That is how our whitelisted set of capabilities can grow with minimum friction. This has been a core part of our success. Because the constructs are written in TypeScript, a language everyone can understand, we started seeing increasing contributions to CDK constructs library from all sorts of places. Teams that were starting to use Silk would hit a hard edge, and instead of merely complaining to SRE, they were willing and able to submit patches or even entirely new constructs. In fact, the list of contributors is 7 times the size of the original team that developed it, from all over the engineering group. What we have found is that with high-level constructs and a familiar language, all engineers can access the infrastructure code, driving adoption. When they hit a snag, they can modify the code to unblock them, and they can easily submit their improvements back to the constructs library, making it more useful for everyone, increasing even more adoption by more engineers who then contribute their new findings, creating a flywheel of autonomy and independence, central to our mission at SRE. But how exactly do these automatically created guardrails work? Here is an example called WebServe-A. To deploy it, we automatically create a deploy role and its associated permissions derived from that config file. And let's say that WebServe-A wants to create Lambda functions. In this snippet, you can see that it can only create Lambdas starting with the wildcard WebServe-A. And in the real policy, there would be the rest of the relevant actions to manage Lambdas scoped to that wildcard. In this way, the deploy role can only affect properly named Lambdas. And this is true for all other resources. In addition, there are policies on IAM actions concerning roles, and they stipulate that we can only affect roles that are named correctly and have the specified permissions boundaries. But how can we ensure that everything is named and bounded? Surely we don't want engineers to meticulously attend to every resource in their stack. Of course we don't. Instead, we use a powerful feature of CDK called aspects. Aspects allow you to traverse every construct in our stack and run arbitrary code to modify those resources. In our case, we have 2 aspects to rename constructs and tag roles with the appropriate permissions boundary. And to make this completely transparent to all engineering teams, all they need to do is to use our stack object, and this will happen automatically, ensuring the generated template exactly matches what the deploy role expects. To show the great work that Matt Tapper and his team have done, I would like to hand over to him to show how all this works at CultureAmp in a demo of our solution.
Thank you, Don. So what I'd like to demonstrate today is how the CDK has helped us to move fast safely. In order to reach this promised land, engineers need to own their own infrastructure. And to do this, we need to get 3 things right. The first is confidence. We must have confidence that what is being deployed is sensible and that it meets our view of best practice. The second is control. We need to maintain control of what can be deployed and what those deployed things can do. And the third is flexibility. So as our view of best practice changes, we must be able to change our constructs, and it should be easy for all to see the benefit. In our first scenario, I'll demonstrate how we maintain confidence in what our engineers ship by using our vetted constructs. I've spun up this AWS Summit demo repository using our Silk platform. I've been asked a few questions, and the repo has been generated with an example CDK app and CI pipeline that is good to go. Let's take a look at the CDK app. So at the top, we have some imports. We are creating the app, setting some config, setting some tags, and the stack is being instantiated down the bottom. Let's jump and take a look at the stack definition. So what we've had generated for us here is a stack with one of our constructs included as an example. At this point, you could clear it out and import what you need for your project. But for us, let's keep what's here and extend it. The function construct is imported from our internal construct library, and it offers a fairly simple interface. And that's because we build in a lot of sensible defaults. Here we only need to provide a few details: name, runtime, handler, and we need to tell it where to get the code from. The interface is much larger than this, but for our purposes, this is all we need. Now, we have a Kinesis log stream deployed to all our accounts. There are a bunch of lambdas hanging off the back of this that forward logs and lambda-generated APM metrics to where they need to go. We want to capture the logs from our lambda, so let's add our log stream subscription construct that will subscribe the Kinesis log stream to our lambda's log groups. To do so, we just need to first import our subscription construct. There we go. And we can now instantiate it down the bottom. We'll give it a name. And we just need to pass to it our functions log group. So there we go. So looking at our stack, we have about 12 lines of code. Let's have a look and see what it generates. We'll need to build our application first, so yarn run build. And once built, we can synthesize our stack and generate a CloudFormation template. Let's take a look at the synthesized stack and confirm that our lambdas function and logstream subscription are created. So we'll just search for the lambda, and there you go. And we'll search for the logstream subscription, and there you go. As you can see, we have a subscription filter that's subscribing the Kinesis logstream to our function. So all up, we have over 300 lines of YAML here. Clearly, there is a lot more going on under the covers, built-in sensible defaults, as it were. It's also code that someone didn't have to write. Okay, so what we have now is a basic stack, and what this first scenario has shown is that by providing vetted constructs with best practice built in, we can gain confidence that the infrastructure being shipped is good. Our second scenario looks at how we maintain control and, in particular, how the CDK helps engineers to do the right thing. As a team, we own a repository that's responsible for rolling out deploy roles and permission boundaries. The user, via a pull request or our Silk tooling, simply needs to provide a project name, target environments, and the constructs they're using. And once approved, a CDK app rolls out permission boundary policies and tightly scoped deploy roles to the target accounts. With control of this repository, we can control what can be deployed and what the deployed resources can do. Now, one of the constraints on the deploy role is that any role created must have a permission boundary attached to it. And this is to prevent privilege escalation. This has the potential to create a whole lot of friction for users who would be on the hook for attaching the permission boundary to all the roles that may be created by the constructs they use. I'd like to illustrate how the CDK makes it easy to address this. So let's go back and look at our CDK app. As you can see, we have a permission boundary set at the top. This follows a standard naming convention. And down the bottom, where we instantiate our stack, you can see that we are passing the permission boundary to it. So let's take a look at our stack. So if you have a look at our stack class, you can see that it's extending from stack. And if we take a look at our imports, you can see that stack is being imported from our internal construct library and not directly from the CDK. So let's take a look at our CDK constructs repo to investigate further. So we're just going to find the stack class. As you can see on the interface, we're asking for a few extra properties, tags, and the permission boundary. Now, what I'd really like to highlight is what we're doing with the permission boundary. As you can see on line 24, we're using an aspect, which is a way to apply an operation to all constructs in a given scope. So let's take a look at our permission boundary aspect. Aspects employ the visitor pattern. Essentially, it traverses or visits all constructs within a stack. And as you can see on line 12, if it finds an IAM role resource, it applies the permission boundary policy to it via a property override. In this scenario, I demonstrated how users don't need to be aware of the mechanics behind our permission boundary requirements. Using aspects allows us to put tight controls around our deployments without it being a burden on our engineers. In our final scenario, I'll demonstrate how, as we find better ways of doing things, we can change our constructs and all can see the benefit. Let's go back and take a look at our demo stack. As you can see, we have our Lambda and LogStream subscription constructs defined. Now, getting logs and metrics to where they need to be is really a concern for all Lambda functions. Users shouldn't have to import this into every stack to get this done. So let's take a look at updating the function construct in our CDK construct library. We'll just copy what we need from here. And we'll find our function construct. Now, the first thing we need to do is import our LogStream subscription construct. There we go. We'll jump down to the bottom. And let's add a convenience method called addLogStreamSubscription. And we'll just paste the code we copied from our stack. Good engineers copy, great engineers paste. We just need to update the code to pass the log group correctly. Now all we need to do is push this code, get it approved and merged, and once it's deployed, the new version is available for use. For us to take advantage of this feature, we just need to update our dependencies to point to the latest. So let's just take a look at our package.json. As you can see, we just need to update the version here. I've already done this to prevent reinstalling. So let's go back to our stack and drop the old code. We can now use the new convenience method instead. So we've now added the Logstream subscription in a nice declarative way. Our code is a bit neater, and the added functionality is available to all. Whilst the SRE team wrote all our initial constructs, what we found nowadays is that contributions from outside our practice outnumbers contributions from within. It's a far more approachable for developers than a wall of YAML. So just to step back again, in summary, we've seen how reusable constructs with sensible defaults and best practice built in gives us confidence in the quality of the infrastructure shipped by our engineers. We've looked at how we provide guardrails, and in particular, how the CDK and the use of aspects prevents our deploy role constraints becoming a burden. And finally, we looked at the ease at which our constructs can be updated and how all can see the benefit. Hopefully this has given you a taste of how the CDK can help you to move faster safely. Thank you.
Thanks, Matt. That was incredible to see how much can get done so quickly. To recap, the old workflow we saw had engineers working in an unfamiliar environment, lots of involvement from SRE, and a slow feedback loop. Today, to start a service, a developer can create a project from a template that contains some basic code, run our Silk CLI that connects up Buildkite and creates a PR for the base infrastructure and guardrails for that service. Once that PR is approved, our system, using our constructs, will deploy to the requested environments. Now the engineer just has to push their code and it deploys. Of course, our story doesn't end here. We are expanding and refining our construct library and our tooling, looking for new ways to safely empower developers to change the world of work.
Thank you, Don and Matt. It was a refreshing insight into the vision, principles, and ensuing implementation to empower teams, enable speed, and ensure security. Every developer can use AWS-provided constructs, including the Layer 3 constructs, which compose popular patterns such as API Gateway, Lambda, DynamoDB, and many, many, many more. CDK supports a number of language bindings. Whether you're a developer who likes spaces or tabs, statically typed or dynamically typed languages, CDK got you covered. Choose a language that makes you most productive. It is a convenient way to get started and become familiar with. Do check out cdkworkshop.com and CDK examples in AWS Samples Git repository. CDK Framework is an open source framework with publicly visible roadmap, and contributions are welcome. There is a rapidly growing global community that is producing remarkable assets and resources benefiting developers around the world. There has never been a better time to be a developer, especially with the newfound autonomy to observe, orient, decide, and build. You joined the AWS Summit to learn, and you can keep the learning going after the summit as well, with resources from AWS training and certification. We offer many free and on-demand digital courses as well as virtual instructor-led training. AWS experts will help you and your team learn to build solutions on AWS. Thank you for attending the session. We'd love to get your feedback. It helps us bring quality sessions to you. Please do complete the survey.